Prior to plunging into the announcement, it's fundamental to understand the significance of what we're discussing. The Large Hadron Collider, LHC, operated by CERN, stands as a remarkable accomplishment in science. Spanning 17 miles, this complex network of superconducting magnets is not only the largest but also the most powerful particle accelerator in the world. It represents an extraordinary portrayal of human ingenuity and intellectual achievement. Remarkably, the LHC is so powerful that it has the capability to recreate conditions similar to those during the birth of the universe. However, as we delve into the vastness of the cosmos, could this machine, which aims to unlock the secrets of existence, inadvertently expose us to more dangerous outcomes? Established in 1954, CERN is one of the world's most esteemed scientific research institutions. With 23 member nations and a vast community of scientists, it serves as a hub for collaboration and innovation. While the LHC is its flagship project, it is only one part of a vast array of particle accelerators and experiments. Imagine it as a racetrack, not for cars or horses, but for subatomic particles racing against each other in a test of speed, precision, and the very nature of spacetime itself. At the LHC, protons are accelerated to nearly the speed of light, mimicking the energy levels present at the moment of the Big Bang. The resulting collisions generate temperatures far hotter than the core of the Sun. A series of magnets directs the protons along their path, while advanced cooling systems maintain the temperature of the magnets at levels lower than outer space. These collisions are designed to take place at 4 distinct points around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, capture data. Each detector serves a unique function, providing a different perspective on the results of these collisions. Together, these detectors act like colossal cameras, capturing the aftermath of the collisions. Researchers sift through the debris to uncover elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that may help decipher the building blocks of our universe. By focusing on the subatomic realm, scientists seek insights into the very nature of the universe itself. However, every new discovery raises even more questions. The LHC is not just a tool. It symbolizes humanity's unyielding curiosity and thirst for knowledge. It embodies our drive to understand the forces that govern existence. Yet, as we push the boundaries of the unknown, we must confront the ethical and existential challenges that accompany this pursuit. What dangers could arise from probing too deeply into the unknown? Could our quest for knowledge open doors to forces beyond our control? At CERN, where the limits of human understanding are tested, an unsettling realization has emerged, one that has sent chills down the spines of even the most seasoned scientists. Brian Cox, a former CERN researcher and a respected voice in particle physics, recently shared a disturbing statement that has both fascinated and frightened people worldwide. According to Cox, the purpose of the LHC is to simulate a miniature Big Bang, a small-scale version of the very event that gave birth to our universe. Cox elaborated on the significance of this goal, explaining the tremendous potential of the LHC for groundbreaking discoveries, such as unraveling the mysteries of dark matter, a mysterious substance that constitutes a significant portion of the universe. The possibility of harnessing the fundamental forces of the universe is undeniably captivating, but it comes with inherent risks. The miniature Big Bang is not just a theoretical concept. It is an actual phenomenon occurring within the LHC. The collider recreates conditions of extreme heat, pressure, and energy, mimicking those at the beginning of the universe itself. Perhaps we are witnessing the dawn of humanity's ultimate understanding. However, with such immense power comes tremendous responsibility. What if something goes wrong? This is not a new concern. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that profoundly altered the course of his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally intersect the path of a proton beam. The beam, traveling at nearly the speed of light, penetrated his skull, entering from the back and exiting through his nose. Despite experiencing a flash of light brighter than 1,000 suns, Bugorsky remained conscious and even walked to seek medical treatment. The aftermath was both fascinating and troubling. He lost hearing in one ear and suffered partial facial paralysis. Remarkably, his cognitive functions remained unaffected, and he continued his scientific work. Bugorsky's experience serves as a stark reminder of the power and potential danger of particle accelerators. The risks associated with a particle collider, like the LHC, are not to be taken lightly. There are legitimate concerns about unforeseen reactions that could alter the very fabric of existence. Some scientists worry about the possibility of creating a miniature black hole within the collider. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, terrifying forces lurking at the edges of the universe. The idea that the LHC could create even a tiny black hole is both fascinating and terrifying. Could such a black hole eventually grow uncontrollably, consuming the Earth from the inside out? CERN scientists have reassured the public that any black hole formed would be incredibly unstable and would dissipate almost instantly. Still, the mere possibility of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we must first consider the basic workings of a particle accelerator. When protons collide at nearly the speed of light, the energy produced is so intense that it can distort the fabric of space-time itself. Imagine a trampoline stretched taut, and then a heavy object is dropped onto it. The fabric bends. If the object is massive enough, it could create a depression so deep that anything nearby would be pulled into it. This simplified analogy provides a glimpse into how the LHC could affect space-time on a quantum level. At this quantum scale, where the laws of physics seem strange and unpredictable, there is a theory suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC could potentially tap into them, possibly creating a gravitational well that forms a tiny black hole. The possibility of such an event has captured the attention of prominent physicists, including the late Stephen Hawking. In his works, Hawking warned of the potential for the Higgs boson to become unstable at extremely high energies, which could trigger catastrophic consequences such as vacuum decay. Esteemed astrophysicist Sir Martin Rees also raised concerns about the LHC's experiments. In his book on the future of humanity, he explored the potential dangers of particle accelerators, emphasizing the catastrophic consequences of vacuum instability. He acknowledged that while the likelihood of such an event occurring was low, even a small chance warranted careful consideration. The stakes are high, and the margin for error is razor-thin. Despite the reassurances from CERN and physicists like Brian Cox, the notion that experiments at the Large Hadron Collider could inadvertently lead to catastrophic outcomes still lingers in public discourse. These fears often stem from a combination of misunderstanding the science and the genuinely awe-inspiring scale of the collider's potential. The LHC's capacity to probe the unknown is unmatched, but it is also this capacity that fuels concern. By recreating conditions similar to the Big Bang, the LHC pushes the limits of human knowledge, exploring realms of physics that have never been observed. This pursuit raises profound questions about the ethics and responsibility of conducting experiments with such unprecedented implications. Balancing discovery and risk. While the potential dangers may sound alarming, it is essential to contextualize them. Theoretical physicists agree that the probability of any catastrophic event is so small that it borders on impossible. For instance, the energies produced in the LHC are not unique. Similar conditions occur naturally in the universe, such as when cosmic rays collide with Earth's atmosphere. If such interactions posed a real threat, Earth and the universe itself would already have been affected. Moreover, scientists involved in the LHC's design and operation emphasize the rigorous safeguards in place. These include fail-safes, redundancies, and extensive peer-reviewed safety assessments. The LHC has operated successfully for years, yielding groundbreaking discoveries like the detection of the Higgs boson in 2012 without any adverse incidents. The philosophical implications. Beyond the technical and safety aspects, the work at CERN sparks philosophical debates about humanity's role in the universe. As we uncover more about the building blocks of reality, we are confronted with existential questions. Are there limits to what we should explore? Could understanding the universe on a fundamental level change our perception of existence in ways we are not prepared for? Some critics argue that ventures like the LHC symbolize humanity's hubris, a willingness to tamper with the fabric of reality without fully understanding the potential consequences. Others see it as a testament to human ingenuity and curiosity, reflecting our insatiable desire to understand our place in the cosmos. The future of particle physics. The LHC is only the beginning of humanity's journey into high-energy physics. Plans are already underway for next-generation accelerators, such as the Future Circular Collider, FCC, which would dwarf the LHC in size and power. These advancements promise to deepen our understanding of the universe, potentially uncovering answers to questions about dark matter, dark energy, and the unification of fundamental forces. However, with these advancements come even greater responsibilities. Future projects will require not only technological innovation, but also global cooperation and careful consideration of the ethical and safety implications of such experiments. A legacy of exploration. Ultimately, the Large Hadron Collider represents the best and most daring aspects of humanity. It is a monument to our collective curiosity and determination to unravel the mysteries of the universe. While the risks are not zero, the potential benefits, such as new technologies, insights into the origins of the universe, and a deeper understanding of our reality, far outweigh them. As we look to the future, the LHC reminds us that progress often requires venturing into the unknown. With careful stewardship, this journey has the potential to unlock some of the greatest scientific discoveries in human history. Whether those discoveries bring answers or more profound questions, one thing is certain. The quest for knowledge will continue to define us as a species. Were we to shape it, it would be so little and temperamental that it would rapidly disseminate, delivering an eruption of energy anticipated by Hawking's hypothesis of peddling radiation. Some have conjectured that the LHC's examinations could open a passage to another universe or aspect. While this thought is generally dismissed by mainstream scientists, it has captured the imagination of many, fueling legends and rumors. What lies beyond our universe? Might we accidentally unleash forces or entities that we do not understand? The idea of creating a portal to hell has even been dramatized in media, amplifying the uncertainty surrounding these experiments. But where did this idea come from? And what does it mean in the context of scientific exploration? The concept of parallel dimensions isn't a new one. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions might be hidden from our senses, but could, in theory, be accessed under extreme conditions. Imagine the LHC as a key, unlocking doors to realms that have been concealed since the dawn of time. When protons collide at energies never before seen on Earth, they might create waves or ripples that probe these hidden dimensions. While this idea remains speculative, it highlights the allure of the unknown. The possibility of discovering other dimensions continues to fascinate the public, even though mainstream scientists remain unconvinced that the LHC will open a doorway to another universe, or to hell itself. Nonetheless, the idea of the LHC being a cosmic key to new realities captivates the imagination of many. Should we worry about the risks associated with the LHC? It's easy to be swept up in sensational headlines and fears of a cosmic disaster. However, the reality is that scientists at CERN are well aware of the potential risks. They have taken every precaution to ensure the safety of their experiments, continuously monitoring and evaluating their work with the utmost diligence. The potential benefits of their research, such as unlocking the mysteries of dark matter, discovering new particles, and advancing our understanding of the universe, are truly remarkable. While these achievements represent a significant leap forward in human knowledge, they come with inherent risks, as do all great advances in science. The LHC's investigations raise profound ethical questions. Could the creation of exotic particles or the exploration of high-energy conditions trigger unforeseen consequences for our planet or the very fabric of reality? These are questions that cannot be taken lightly and require thoughtful consideration of the broader implications of scientific progress. In conclusion, the Large Hadron Collider stands as a testament to human ingenuity and curiosity. It has already made groundbreaking discoveries in particle physics, shedding light on the mysteries of the universe. Yet, as we venture into these uncharted territories, we must remain vigilant and mindful of the risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without its challenges. The LHC represents the cutting edge of scientific exploration, where theory meets experimentation, and where the very foundations of our understanding of the universe are being tested. The journey of discovery is rarely without risk, and the LHC is no exception. It pushes the boundaries of physics, striving to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. As we continue to explore these frontiers, we must acknowledge the profound ethical and existential questions that arise from manipulating the forces of the universe. The risks of potential negative outcomes, whether for our planet or for the very fabric of space-time, remain a challenge that requires careful reflection. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer a glimpse into the vast unknown realms of science that await discovery. As we stand on the brink of revelation, the journey to unlock the secrets of the universe demands both ambition and caution. The LHC is not only the pinnacle of human technological achievement, but also a powerful tool with the potential to reshape our understanding of everything, from the smallest particles to the grandest cosmic phenomena. With each breakthrough, new questions arise, opening new avenues of thought and investigation. The journey of scientific discovery, though fraught with uncertainty, holds the promise of revelations that could redefine how we perceive the universe, our place in it, and the very laws that govern it. Perhaps the most significant aspect of the LHC's experiments lies at the intersection of theory and reality. For decades, physicists have grappled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to unify these forces under a single framework, a theory of everything. The LHC has been instrumental in providing insights and experimental evidence that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics, but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas associated with such experiments are significant, yet the pursuit of knowledge has always carried risks. When those risks involve altering the very fabric of reality, the stakes become even higher. Could an experiment at the LHC inadvertently trigger a phenomenon we do not yet understand, leading to consequences that are difficult, if not impossible, to predict? This is a question that scientists, philosophers, and ethicists alike continue to ponder. As we venture into these realms, we must consider the responsibility that comes with wielding such immense power. Yet, despite the potential dangers, few would argue that the pursuit of scientific progress is not worth the risk. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe are immense. The discoveries made by the LHC thus far have already transformed the scientific landscape, from the identification of the Higgs boson to advances in our understanding of dark matter. These achievements have far-reaching implications not only for physics, but for countless other fields that rely on this fundamental knowledge. As we push the boundaries of what is possible, the LHC serves as a reminder that science is never without its uncertainties. No experiment is entirely without risk, and the LHC, as extraordinary and powerful as it is no exception. Yet, with every risk comes the potential for monumental discoveries. The LHC symbolizes humanity's relentless pursuit of knowledge, a quest to answer questions that have puzzled us for centuries. Ultimately, It is this curiosity that drives us forward. The desire to understand the universe, to peer into the depths of reality, and to uncover the forces that govern everything from the smallest particles to the largest galaxies. Scientific progress, as exemplified by the LHC, may carry risks, but it also represents the pinnacle of human achievement in the field of particle physics. It is a tool that allows us to explore the deepest questions of existence, challenge the very laws of nature, and seek answers to mysteries that have eluded us for centuries. As we advance further into the mysteries of the universe, the Large Hadron Collider serves as a beacon of human ingenuity and perseverance. It reflects our determination to probe the unknown and expand the horizons of what is scientifically and technologically achievable. However, this journey into the uncharted territories of particle physics also underscores a profound philosophical truth. The pursuit of knowledge often comes with ethical dilemmas and existential challenges. At the heart of these challenges lies the question of responsibility. Should humanity proceed with experiments that might have unintended consequences, even if the probability of catastrophic outcomes is exceedingly small? This question is not unique to the LHC, but applies to many domains of scientific inquiry. Whether it is genetic engineering, artificial intelligence, or the manipulation of subatomic particles, the potential for both profound benefit and unintended harm requires a balance of ambition and prudence. For the LHC, the stakes are especially high because its experiments touch upon the fundamental building blocks of the universe. The potential to discover new particles, uncover hidden dimensions, or even solve the mysteries of dark matter could revolutionize our understanding of existence. Yet these possibilities also come with the recognition that we are treading into unknown realms, territories where our current understanding of physics may no longer apply. The LHC's achievements thus far stand as a testament to what humanity can achieve when driven by curiosity and determination. The discovery of the Higgs boson, for instance, validated decades of theoretical work and provided critical insights into the mechanism by which particles acquire mass. This breakthrough has had implications not only for particle physics, but also for cosmology, helping to shape our understanding of the early universe. Similarly, ongoing research into dark matter and energy, a mysterious component that makes up the majority of the universe, continues to intrigue scientists and the public alike. Although invisible and elusive, dark matter exerts a gravitational influence that holds galaxies together. Unlocking its secrets could answer some of the most profound questions about the structure and evolution of the cosmos. Yet, as we look to the future, it is vital to maintain a dialogue that includes not only scientists but also ethicists, policymakers, and the public. The decisions we make about how to use tools like the LHC have implications that go beyond the realm of science. They touch upon fundamental questions about our values, priorities, and responsibilities as stewards of knowledge. The pursuit of science is, at its core, a deeply human endeavor. It reflects our desire to understand the world around us and to find our place within it. While the path forward may be fraught with uncertainties, it is also filled with unparalleled opportunities for discovery and growth. In the end, the story of the LHC is not just a story of scientific achievement. It is a story about humanity itself, about our capacity to dream, to question, and to explore. It reminds us that the universe is vast and mysterious, and that our journey of understanding is far from over. As we continue to push the boundaries of what is possible, we must do so with courage, humility, and a deep respect for the unknown. The Large Hadron Collider, for all its complexity and power, is ultimately a tool, a means by which we seek to unravel the deepest mysteries of the cosmos. What lies ahead is uncertain, but one thing is clear. The quest for knowledge will continue to inspire and challenge us, shaping the course of human history and illuminating the path toward a future filled with endless possibilities.